Hello and welcome back. This is part 2 of Unit 6 UGC NET JRF Forensic Science about explosives. Explosives are the substances which undergo rapid chemical changes without an external supply of oxygen, and they will yield large amount of energy, heat, etc. The difference between fire and explosive is the speed or the rate of the reaction. The reaction is combustion reaction. An explosive mixture contains an oxidizing and a reducing agent. And there are various explosives that are used in other industries such as medicine, some nitrate esters in paint, cellulose nitrate, etc. Vapor explosion is the ignition of fuel due to air mixture instead of explosive. In low explosives, the fuel and oxygen are physically mixed, whereas in high explosion, oxygen and fuel are combined in a single molecule. Alginates or salts of alginic acid have 200 to 300 times binding capacity, and these are added to improve their resistance, the explosive's resistance to moisture, and it will increase its viscosity. Alex or aluminum powder increases air blast and burning rate of solid explosive factor by 2. It also raises the reaction temperature, enhance heat of detonation, increase bubble energy in underwater weapons, improve air blast, and create an incendiary effect. Acardite is used as stabilizer for gunpowder. It is of three types: acardite 1, 2, and 3. Centralite is used as stabilizer in double base gunpowder. The classification of explosives based on their chemical structures, they are classified as organic, inorganic, and mixture. In organic, we have two categories: organic nitroexplosives and organic peroxides. Organic nitroexplosives are further divided into nitroaromatic, for example TNT, DNT, etc., nitrate esters, Ng, PET, and NC, nitramines, RDX, HMX, etc. Organic peroxides, TATP, HMTD. Inorganic salts, ammonium nitrate, fuel oil, or ANFO. Mixtures of oxidizing and reducing reagents, black powder, potassium chlorate, and sugar, etc. Based on their use, explosives are classified as military explosives, which involves TNT, PET, and RDX, HMX; industrial or commercial explosives that are used for mining, quarrying, tunneling, etc. These are dynamites, ANFO; immersion explosives; illegally manufactured improvised explosives, TATP, potassium chlorate, and sugar mixture, etc. On the basis of their place in detonation chain, explosives are further classified into primary, boosters, and main charge. Primary explosives are uh, the mercury fulminate, lead stiphanate, lead azide. These are the high explosives. Boosters, PETN, main charge, TNT or RDX. These are the examples. So based on explosive properties, they are further classified into high explosives and low explosives. High explosives are PET and RDX, HMX, TNT. Low explosives or propellants are smokeless powders. These are used in basically in firearms. Black powder, semi-smokeless powder, which is also known as less smoke powder. Semi-smokeless is the mixture of smokeless and black powder. So propellant used in small arms are treated with methyl or ethyl centralate to serve as stabilizer. Propellants are further divided into single base, double base, triple base, and high energy. Single base are used in small arms and large caliber guns. Double base used in small arms, machine pistols, small cannons, and mortars. Triple base uses large caliber artillery and tank guns, high energy in high velocity tank guns. Other type of explosives are gelignites or gelatin dynamites, which are composed of nitrocellulose and nitroglycerine in the ratio 1 is to 20. Another are permitted explosives. They have low shock wave pressure and positive oxygen balance. They are used for blasting as to avoid the risk of secondary explosion and vapor explosion. They have low shock pressure. Sodium chloride can be used as a flame suppressant to avoid accidents. Pyrotechnic explosives used for special effects such as light, sound, smoke, delays, etc. These are the the explosives used in Diwali are the pyrotechnics ones. These are the mixture of oxidizing and reducing agents. So when they have oxidizing as well as reducing agent, they are capable of self combustion. All pyrotechnics are solid in nature, so the solid particle will undergo pyrolysis. Nuclear explosive is an explosive that derives its energy from nuclear reactions. The various types of explosion are: first, physical explosion. It is also known as boiling liquid expending vapor explosion, as in the case of uh, blasting of cooker. 1.4 to 7.6% of cooking gas forms explosive mixture with air. So when the steam boiler or the cooker is over pressurized, it gets exploded by the conversion of potential energy into kinetic energy. Atomic or nuclear explosion. This explosion emit infrared, ultraviolet, gamma radiation, and it is very toxic, or its potency is very high. Examples are nuclear explosion at Hiroshima and Nagasaki. The places are yet giving toxic, producing toxic surroundings or toxic air. The air is very toxic there. The air, the soil, etc. Exotic explosions are due to natural causes such as volcanic eruption, asteroid or meteoroid impact event, hydrothermal event, astronomical event, etc. Chemical explosion in which the state of the substance is changed. It is of two types: deflagration and detonation. Deflagration is layer by layer burning. It is a process of combustion which transfer heat at subsonic speed across the surface of an explosive. So, example, burning of crackers. So, deflagration is in low explosives. Feibert's law applies to the reaction of solid propellant grains to generate hot gases. So, this layer by layer burning is stated in Feibert's law. So, deflagration is a result of combustion at subsonic speed, and the compounds that undergo deflagration are pyrotechnics and propellants or low explosives. Detonation, it is the rapid combustion of substance due to supersonic shock wave, and it is observed in cases of high explosives, and it will cause more destruction. It will release more heat, more light. The effects of explosion: bomb seat is the point of origin from which explosion took place. Blast pressure, pressure from the escaping gases when explosion is there. So the surrounding air will get compressed, and this result in a strong wave away from the bomb seat. So this is known as the positive pressure phase. But this compression and this moving will create a vacuum. So to fill up that space, there is another uh, movement of wave towards the blast point. So this is known as negative pressure phase. Fragmentation effects are due to flying debris or shrapnels, and thermal effects are due to heat. The volume of crater is calculated by the formula V is equals to Kw to the power 1.4, where V is the volume of the crater, W is the weight of explosive in pounds, and K is the constant, that is zero point 0.4. Low and high explosive, as I have already discussed. Low explosives are a result of deflagration. High explosives are a result of detonation. In low explosives, subsonic pressure wave is there. In high ones, supersonic pressure or shock wave is there. So the main effects of low explosive is to push, whereas high explosive is to shatter. High explosives are further divided into two: initiating and non-initiating. Initiating ones are get detonated by slightest shock or spark. Non-initiating ones get detonated when there is major shock. Example, dynamites and military explosives. Low explosives versus high explosives. The detonation velocity of low ones is less than 3280 fps, whereas of high explosive is more than that, 3280. Low explosive has less shattering effect and more pushing effect. High explosives have more shattering effect. Low explosive have wide diameter crater. High explosive have small diameter crater, but it is deeper. Low explosive bigger fragments, high explosive small fragments. Low explosive intense heat effect, little or moderate blast effect. High explosive severe blast effect. Low explosive dependent on confinement. High explosive independent of confinement. Low explosive shows bending effect. High explosive show cutting effect. Explosive train or series of explosion. Low explosive train in which the end product is low explosive. High explosive train in which the end product is high explosives. Example of low explosive train is when black powder is used to detonate smokeless powder. High explosive train, uh, the detonator used may be blasting cap or other primary explosive. If other secondary explosives other than main charge are present, these are known as boosters. Primer cord is a detonating cord with a core of PETN and is encased in a textile outer jacket with detonating velocity of approx 7000 meter per second. Primary and secondary explosives. So, when heat is applied to the black powder, oxygen is liberated from potassium nitrate and get combined with charcoal and sulfur to produce heat and gases. What are the effects of explosives? Ammunition or skyrocket smashing or shattering effect, that is also known as brisance, is observed in case of explosives. Ammunition is the assembly in which propellants, primers, etc. are there that are used in a firearm. Primary explosives are very sensitive to heat, shock, friction, and they detonate violently. For this reason, they are used as a detonator for other explosives and are also known as primers. The formulation containing nitroglycerin are detonator sensitive. PETN can be used as the detonator. Secondary explosives are comparatively less sensitive to that of primary explosives and are further classified into boosters and main charge. Examples of secondary explosives are TNT, PETN, RDX, HMX, etc. Tertiary high explosives are extremely insensitive. and they require boosters, example ANFO. The various explosive compositions are composition A, RDX 91% and wax 9%, composition B 60% RDX, 40% TNT and 1% wax, cyclotol 60 to 75% RDX and 25 to 40% TNT, Torpex 42% RDX, 40% TNT, 18% aluminium, C2 80% RDX, 20% plasticizer, C3 77% RDX, 23% plasticizer, C4 91% RDX and 9% of plasticizer, C20 hexanitro-hexaaza isovertzetane, it is a nitramine, picritol TNT plus ammonium picrate, ASA mixture, lead azide, lead stiphanate and aluminium, Cortex PETN. Pentolite is PETN plus TNT, Semtax is RDX PETN plus polybutadiene styrene plus oil, PTX1 RDX TNT tetrail, PTX2 RDX TNT PETN, Ametax TNT plus ammonium nitrate plus RDX, Ammonal TNT ammonium nitrate and aluminium powder, Tetritol TNT and tetrail, Octol HMX plus TNT, HTA3 HMX TNT aluminium, Baratol barium nitrate and TNT, Tritonal TNT with aluminium powder, Amatol TNT plus ammonium nitrate, MOX RDX TNT aluminium barium nitrate, calcium stearate, graphite and wax, Military Dynamite RDX TNT SAE10, that is motor oil and cornstarch, PEK tetrail plus plasticizer. So higher the melting point or decomposition, higher will be the detonating power needed. So the performance would be HMX, its molecular formula is molecular mass is 280, so its detonating power would be more, as the melting point will be directly proportional to the molecular mass. RDX 204, PETN 141, Tetrail 129 and TNT 81. Thank you for watching. Stay tuned.